The continuation here, the important one is introduction to soft computing, and that is very important for the examination point of view also. Applications of soft computing. ఓకే, సో ఇదే రకంగా మనం ఎగ్జామినేషన్ స్టైల్లో కూడా రాసుకోవాలి. ఓకే, సో టు గెట్ ఏ గుడ్ మార్క్స్, కీవర్డ్స్ నేను ఏం చెప్తున్నానో అవి పోస్ట్ చేస్తున్నాను మెసేజ్లో. అప్పుడు కీవర్డ్స్ని బట్టి మనం యాక్చువల్గా ఏంటంటే వీ హ్యావ్ టు టేక్ those keywords into consideration and write most of them in our own. Applications of soft computing, and uh, and we have learned that soft computing is the partnership of multiple techniques which helps accomplishes a particular task. The real world problems that contains certain and imprecise information can be solved using the soft computing techniques. Okay, so what you are in a position to answer these review questions. What is computational paradigm? State difference between hard computing and soft computing. Write a short notes on soft computing. What are the premises and guiding principles of soft computing techniques? Give any 3 applications of soft computing. Types of soft computing techniques. The module 2 is soft computing techniques types. The objectives of this chapter is to give the overview of the various soft computing techniques. Okay, so in this we learn the types of soft computing techniques: fuzzy computing network, neural network, genetic algorithms, associate memory, adaptive resonance theory, classification, clustering, probabilistic reasoning, so Bayes-Tay network. These things we have to describe in this unit. Applications of neural network is very important. Components of neural network is very important. Components of neural network, what are different various components are there, and applications are concerned with applications of neural network is very important. Main applications of neural network is image recognition, pattern recognition, self-driving car trajectory prediction, so image SMARM filtering, medical diagnosis. This is very important. I'm posting on the chat box. Applications of neural network. You don't miss these key points. As a well-wisher, I'm telling. That's why I'm giving more innovative and creative presentations, and I'm recalling our previous presentations also to get a perfection for you. A presentation కనుక ఉంటే మీకు ఈజీగా తక్కువ టైంలో ఓకే ఈజీగా ప్రిపేర్ అవ్వచ్చు to get a good marks, of course. Okay, so that's why the reason we look back into these keywords. Applications of neural network is hard image recognition, pattern recognition, self-driving car trajectory prediction, image SMARM filtering, medical diagnosis, like that. Okay, so here the components of neural network also very important. Neuron model, information process of the artificial neural network consists of following. This is very important. Components of neural network. These are the compulsory and very important for the examination point of view. Components of neural network. Components of neural network. Components of neural network. Neural model, the information process unit of artificial neural network. Okay, neural model consists of the following. Neural model consists of the following. The information process with the artificial neural network. Neural model consists of input, weight, activation functions. These keywords these are very important actually. Input, weight, activation functions. Input, weight, and activation functions. So coming into architecture, the arrangement of neurons and links, connecting neurons, every link. Okay, connecting neurons, every link. Architecture, the arrangements of neurons and links, connecting neurons to where every link. Okay, the connecting of various links. So the following are the different artificial neural network architectures. Single layer feed forward network, multi-layer feed forward network, single node with its own feedback, single layer recurrent network, multi-layer recurrent network, like that. These are the different types of architectures is concerned. Single layer feed forward network, multi-layer feed forward network, single node with your own feedback, single layer recurrent network, and multi-layer recurrent network, like that. Okay, so those are the architecture types actually. A learning algorithm for training artificial neural networks by modifying the weights in order to model a particular learning task currently on the training examples. Following are the different types of learning algorithms: supervised learning, unsupervised learning, reinforcement learning. These are the learning algorithms. A learning algorithm. A learning algorithm. A learning algorithm for training artificial neural networks by modifying the weights in order to model a particular learning task correctly on the training examples. Following for different types of learning algorithms: supervised learning, unsupervised learning, reinforcement learning. Supervised learning, unsupervised learning, and reinforcement learning. Okay, so these are the different types actually. This is very important. Genetic algorithms plays an important role. Genetic algorithms to work on the practically to develop any system. So in I'm in association with scientists and industry people now. That's why the reason regularly I'm monitoring. So the practical oriented systems, also develop based on these concepts only. Okay, these concepts are essential to develop any sort of innovations and creations practically. Okay, so innovations and creations to do practically, these sort of things are very important actually. Okay, these are very important. That's why the reason I'm highlighting in a sequence once you observe. Okay, so genetic algorithms. Okay, so which are some of process for the natural evaluation get performed directed random search through a given set of alternative with aim of finding the best alternative with respect to given criteria of goodness. These criteria are required be expressed in terms of an object function, which is usually referred to as fitness function. Biological background. All living organisms consists of a cell. This is very important. In each cell, there is a set of chromosomes, which are strings of DNA and serves as models of the organization. A chromosome consists of genes, a blocks of DNA. Each gene encodes a particular pattern. Basically, can be said to be a bone encodes a trains. All living organisms consist of a cell. In each cell, there is a set of chromosomes, or there which are strings of DNA, and serves a model of organism. A chromosome consists of genes and blocks of DNA. Each gene encodes a particular pattern. Basically, it can said to be each gene encodes its steps involved in the genetic algorithm. First one is initialization. Steps involved in the genetic algorithm. What are the steps are involved? What are the different steps are involved in this genetic algorithm? That is important. Initialization, defining the population for the problem. First one. Second one is fitness function. It calculates fitness function for all chromosomes in the population. Selection. Two fittest chromosomes are selected for the producing the offspring. crossover information in two chromosomes is exchanged to produce the new offspring. Mutation. It is a process of promoting diversity in the population. Benefits of genetic algorithm. Easy to understand. Benefits of genetic algorithm. This is very important. Easy to understand. Genetic algorithm is easy to understand. It is very easy to understand. We always get answer, and the answer that gets better with time. Get answer with better with time. Good for noisy environment. There is no noise here. It's a noiseless environment, of course. Genetic algorithm is a noiseless environment. Good for noisy environment, actually. Okay, there is no noise. Automatically, the efficiency is good. Flexible in formatting and building blocks of hybrid applications. Formatting and building blocks of hybrid applications. Formatting and building blocks of hybrid applications. Has sustainable history and range of use. A sustainable history and range of use. Supports multi-objective optimization. Supports multi-objective optimization. Modular separate from application. Modular separate from application. Modular separate from application. Applications of genetic algorithm. Recurrent neural network. Mutation testing. Code breaking. Filtering and signal processing. Applications of genetic algorithms are very important. Applications of genetic algorithm. Recurrent neural network, mutation testing, code breaking, filtering and signal processing. Recurrent neural network. Mutation testing. Code breaking. Filtering and signal processing. Filtering and signal processing. Once again, I am repeating the applications of genetic algorithm. Recurrent neural network, mutation testing, code breaking, filtering and signal processing. Associate memory. Okay, an associate memory is a content addressable structure that maps set of input patterns to a set of output patterns. The above what I mentioned, they are very important, heart of the presentation. The associate memory are of two types: auto-associative and hetero-associative. An auto-associate memory retrieves a previously stored pattern that most closely resembles the current pattern. In a hetero-associate memory, the retrieved pattern is in general different from input pattern, not only in content but possibly also type and format. So, here we should see the structure of the description of the associate memory. So the CRISPR Columbus and CRISPR Columba and the output. So there you can observe the various parts here: content, addressable memory, input and output. So just we mentioned some names like that. Okay. So a content addressable memory is a type of memory that allows the recall of data based on degree of similarity between the input pattern and the pattern stored in memory. It refers to a memory organization in which the memory is accessed by its content and not or opposite to an exact explicit address in the traditional computer memory system. This type of memory allows the recall of information based on the partial knowledge of its contents. The simplest artificial neural network associate memory is the linear associated. The other popular artificial neural network models used as associate memories. So are Hopfield model and bidirectional associate memory. So ART stands for adaptive resonance theory. Now we will discuss about the adaptive resonance theory. So in this, the word resonance is a concept, just matter of being within a certain threshold of second similar measure. The basic ART system is an unsupervised learning model like many iterative clustering algorithms where each case is processed by finding the nearest cluster seed that resonate with the case and update the cluster seed to be closer to the case. So if so seed resonate with the case, then a new cluster is created. Here, ART as a theory of human cognitive information processing. The emphasis of ART neural network lies at unsupervised learning and self-organization to mimic biological behavior. Self-organization means that system must be able to build a stable recognition categories in real time. The unsupervised learning means that a network learns a significant patterns based on the inputs only. There is no feedback. There is no external teacher that instructs the network or tells will category a certain input belongs. The basic ART system is an unsupervised learning model. The model typically consists of the first one is a comparison field and recognition field composed of neurons. Second one, a vigilance parameter. The third one is a REST module. It's comparison of the field and recognition field. The comparison field takes an input vector, so and transfer it to its best match of the recognition field. So the best match is the single neuron whose set of weight vector matches most closely to the input vector. Each recognition field neurons outputs a negative signal proportional to the neuron's quality of the match to the input vector to each of the other recognition field neurons and inhibits their output accordingly. Recognition field thus exhibits so lateral inhibition, allowing each neuron in its to respect category to which the input vectors are classified. Vigilance parameter. It considerable influence of the system memories. The subpoint is higher vigilance products highly detailed memories. Lower vigilance results is more general memories. REST module. After the input vector is classified, the REST module compares the strength of the recognition match with vigilance parameter. If the vigilance is the threshold met when the training commences, else the firing recognition neuron is inhibited until a new input vector is applied. Training ART based neural network. Training um, commences only upon completion of such procedure. What happens in this? Um, what happens in this such procedure? The recognition neurons are disabled by one. Just you have to observe this flow chart. What I am giving in the below, I will give one by one. We can reset the function until the vigilance parameter is satisfied by a recognition match. So if no committed recognition neurons match meets the vigilance threshold, then an uncommitted neuron is committed and adjusted towards matching the input vector. Methods of learning. So slow learning method. Here, the degree of training and recognition neurons weights towards the input vector is calculated using the differential equations and thus depends upon the length of the time and the input vector is present. Fast learning method. Here the algebraic equations are used to calculate the degree and degree of weight adjustments to be made and binary values are used. Types of, we have very important one is types of ART systems that is very useful in the practical oriented applications. In the uh, in the practical oriented implementations, it is very much useful. Types of ARTs. What I'm highlighting the keywords in my chart box, you should observe very clearly. They are purely practical. They can be able to apply each and every one in the practical aspect. Okay, so we have to develop. Okay, we shall develop the products based on these points. Okay, so that's why the reason you should follow this practical. What I'm highlighting the key points, you should be take it very seriously. You are in a position to interpret and analyze and try to concentrate more on those points, actually more on those points. Okay, so because they have a plenty of applications. ART1, the simplest variety of ART networks accept only the binary inputs. ART1, the simplest variety of ART networks accept only the binary inputs. ART2, it extends the network capabilities to support continuous inputs. ART2, it extends network capabilities to support continuous inputs. The fuzzy ART, it is implemented the fuzzy logic to ART's pattern recognition, thus enhances generalized ability. One very useful feature of fuzzy ART is complement coding, a mean of incorporating the absence of features into the pattern classifications, which goes a long way towards preventing the inefficient and unnecessary category prolifications. This is fuzzy ART. So ART, it may MP, also known as a predictive ART. It combines two slightly modified ARTs, maybe two ART1 and two ART2. So they are into supervised learning structure where the unit takes input data to the second unit takes the correct data output data. So minimum possible adjustments to vigilance parameter the first unit in order to make a correct classification. So just to understand ART and ART2, mixing of both ART1 and ART2 implies both fuzzy ART and ART map. That is nothing but a mixing, of course. Okay, basic thing is ART1 and ART2 are functions. So classification is supervised learning. Classification algorithms is used to predict the category values. Training is provided to identify the category of new observations. The program learns from given data set or observations and then classifies new observation into number of classes or groups. Classes are also called as targets or labels or categories. Okay. Supervised learning. This one is classification of algorithms. This is very, very important. Application classification and classification algorithms. I want to highlight it. Okay. Classification algorithms. Classification algorithms. Logistic regression. Logistic regression. Logistic regression. Narrow Bayes. Just observe these keywords very particularly. You should observe very seriously. Okay, how the algorithm's names is. Okay, this is the future. Suppose the genetic algorithm has a lot of importance. For example, I want to highlight one type of algorithm, very popular algorithm, that is genetic algorithm. If we take a medical applications, we want to identify the condition of a patient. Okay, what are its symptoms? Everything we can do that by using the genetic algorithm because it's connected with the cells of the body. Okay, so it's related with. We can develop an excellent coding for that. Okay, so automatically the our program or software can give the results. Okay, by interfacing with a human interface, the condition of a body. Okay, everything it will give the perfect report. Okay, with several medical diagnosis tests also cannot give an efficient results. but this genetic algorithm can give a results. Likewise, these algorithms also have one of applications, practical oriented applications. Okay, that's why I'm highlighting in the chart box each and every thing. K nearest neighbor, K nearest neighbor. This is one type of algorithm. Without algorithm, there is no coding part. Decision tree. We should develop all those things in the practically. Decision tree. You can understand these algorithms more well based on the practical oriented applications. Random forest. Application of classification. Email spam detection. Application classification. Application classification. Email spam detection. Speech recognition. I'm giving innovative points. Okay, it is very difficult to gather these points also. Okay, because I'm working on the practical oriented one, that's why the reason I'm giving in a simple way. Okay, so these points itself has a lot of importance in the practical applications. Identification of cancer tumor cells. Biometric identifications. Clustering. This is a very important topic. Clustering is a type of unsupervised learning method. Clustering is basically an unsupervised learning method. It's a type of unsupervised learning method. Clustering is a type of unsupervised learning method. In this learning, we draw references from data sets consists of input data without labeled responses. Generally, it is used as process to find meaningful structure, explanatory, underlying process, generative features, and groupings inherent in a set of examples. Its task to provide the population of data points into several groups. Data points into the same group are similar to the other data point in the screen to the data points in other. Clustering determines the grouping among the unlabeled data present. There is no criteria for a good clustering. It depends upon the criteria that user fits the needs of the user. Cluster method, density based methods, hierarchical based methods. So, agglomerative bottom up approach, diversive top down approach. Okay, partitioning methods, grid based methods, applications of clustering in different fields, marketing, biology, so incidents, city planning, earthquake studies. So probabilistic reason, the probabilistic reason is a way of knowledge representation where we apply the concept of probability to indicate the uncertainty in knowledge. In probabilistic reasoning, we combine the probability theory with logic to handle the uncertainty. We use the probability in probabilistic reasoning because it provides a way to handle the uncertainty that is the result of someone's laziness and ignorance. In the real world, there are lots of scenarios where the certainty of something is not confirmed, such as it will rain today, the behavior of someone for some situations, a match between, that's the meaning of probability, I think. Okay, between the two teams or two players. These are probably say, sentences for which we can assume that it will happen, but not sure about it. So here we use probabilistic reasoning. Need for a probabilistic reason in artificial intelligence. Number one, when there are unpredictable outcomes. The number two, when specifications or possibilities are predictive becomes too large to handle. So the third one, when an unknown error occurs during an experiment, they are very important. Need for probabilistic reason in artificial intelligence. It's a very important actually. Okay, need for probabilistic reasoning in artificial intelligence. All of you observe my chat box very clearly. I am posting the practical oriented points, okay, application oriented points, which I am working practically. Okay, so these points they plays an important role. Okay, so you should highlight or do a more analysis and innovation on the practical oriented points. The first point is when there are unpredictable outcomes, need for probabilistic reasoning in artificial intelligence. The first point is when there are unpredictable outcomes. That's why I told the percentage of rain. That's an unpredictable outcome. One of them. There are too many things are like that unpredictable outcomes. Okay. The second one is when specifications or possibilities of predict becomes too large to handle. When specifications or possibilities of predicts becomes too large to handle. When an unknown error occurs during an experiment. An unknown error occurs during an experiment. An unknown error occurs during an experiment. Okay. In probabilistic reasoning, there are two ways to solve the problems with uncertain knowledge. This is it's itself an uncertain one. One is Bayes rule, other one is Bayesian statistics. These are the two rules here. Automatically, the event is an uncertain one. To solve these uncertain ones, there are two methods are there. One is Bayes rule and the other one is Bayesian statistics. Bayesian networks are very important. Bayesian network is also known as Bayesian. So brief network, decision network, or Bayesian model. It deals with the probabilistic events and solves the problems which has uncertainty. Bayesian networks are a type of probabilistic graphical model that uses Bayesian interference for probability computations. Bayesian networks aim to model conditional dependency and therefore caution by representing conditional dependency by edges in a directed graph. Through these relationships, one can efficiently conduct interference on the random variable in the graph through the use of factors cloudy, sprinkle, rain, wet grass. Just observe the probabilities. True, 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 false, false, true, false, false, like that. True, what happened, false, what happened. A Bayesian network is a directed, okay, a graph. It's a graph in which edge corresponds to conditional dependency and each node corresponds to a unique random variable. Formally, if an edge A, comma B exists in the graph connecting random variables A and B, it means that P of B by A is a factor in joint probability distribution. So we must know P of B by A for all values of B and A in order to conduct inference. Okay, the Bayesian network are two mainly has two components: causal component, actual members. Each node of the Bayesian network has a condition probability distribution. Okay, so P of x by y commas some conditional probability. Of course, you can apply to anywhere. Okay, in any node point of view. This is very important. Applications of Bayesian networks. Medical diagnosis. The first point is medical diagnosis. The next one is management efficiency. Management efficiency. Biotechnology. Based networks are very much useful in the biotechnology. Okay. In this chapter, we have learned different techniques used in soft computing, fuzzy systems, can be used when we want to deal with uncertainty and imprecision, adaptivity and learning abilities in the system can be built using the neural computing to find the better solution to the problem. Genetic algorithm can be applied. The pattern can be retrieved from memory based on the content and not based on the address. Is called associate memory. Please try to see these points. Find the input pattern's closest resemblances in the memory. Can also be done with adaptive resonance theory. Classification is based on supervised learning, usually used for predictions, and clustering is based on unsupervised learning. Probabilistic reasoning is Bayesian networks are based on the probability of the event occurring. Here, the important review questions is write a short notes on fuzzy systems. What is artificial network? Explain its components and learning methods. The third one is write a short notes on genetic algorithm. The fourth one is explain the working of adaptive resonance theory. The fifth one is write a short notes on associate memory. The sixth one is compare the classification techniques and clustering techniques, classification technique and clustering technique. The seventh one is write a short notes on probabilistic reason. Eighth one is write a short notes on ballistic networks. That means you should know about fuzzy systems, artificial neural networks, and its components. Genetic algorithm. That's already very important in practical. I highlighted adaptive resonance theory, associate memory. So clustering techniques, so probabilistic reasoning, Bayesian networks, they are very important. Introduction to artificial neural network and supervising network. What are the objectives? What are the basic concepts? Okay, so introduction to artificial neural network, overview of the biological neural network, human brain versus artificial neural network, characteristics of artificial neural network, basic models of artificial neural network, basic models of artificial neural network. Okay, the models, symptomatic introduction. The topics we have to discuss is learning based model, activation function, terminologies of artificial neural network. So, and MC-Pitts neuron, concept of linear separability, Hebb training algorithm, perception network, adaptive linear neuron, so training algorithm, testing algorithm, multiple adaptive linear neurons and architecture, okay, and its review questions, of course. Objectives what we have to meet in this chapter is in this the fundamentals of artificial neural network. The first point is fundamentals of artificial neural network. The second point is understanding between the biological neuron and artificial neuron. The third one is working on a basic fundamental neuron model. The fourth one is terminologies and terms used for better understanding in artificial neural network. And the fifth one is the basics of the supervised learning and perception learning rule. The sixth one is overview of adaptive and multiple adaptive linear neurons. Basic concept is neural networks are information processing systems that are implemented to model the working of the human brain. It is more computational model used to perform tasks in a better optimized way than the traditional systems. The essential properties of biological neural networks are considered in order to understand the information processing tasks. This indeed will allow us to design abstract models of artificial neural networks which can be simulated and analyzed. Introduction to artificial neural networks. Artificial neural networks is a information processing systems that process characteristics with biological neural networks. And artificial neural networks consists of large number of highly interconnected processing elements called nodes or unit or neurons. The neurons operate in parallel. Every neuron is connected to other neuron through communication link. So with associated ways which contain the information about input signal. These processing elements are called neurons or artificial neurons. Overview of the biological neuron. Overview of the biological neuron. So, biological neural network. So here, what are the this is you can observe the structure here, the different parts in the biological neuron. What are the different parts are there in the biological neuron? You should observe here the soma, axon, and dendrite and synapses. These are the different biological neuron. Schematic diagram of neuron. Okay, so here the fact that human brain consists of large number of neurons. Human brain is itself consists of large number of neurons with numerous interconnections that process information. The term neural network is usually referred to the biological neural network and that process and transmits information. This is very important. Human brain consists of large number of our human brain consists of large number of neurons with numerous interconnections that process information. The term neural network is usually referred to the biological neural network. The neural network, this neural network is usually referred to biological neural that process and transmits information. The biological networks are a part of nervous system. The biological neurons consists of three major parts. Soma or cell body contains the cell molecules. In general, processing occurs here. Processing is occurs here only. Soma or cell body contains the cell nucleus. In general, processing occurs here. So dendrites, branching fibers that provides from the cell body or soma. The nerve is connected to the cell body. Axon, it carries the impulses of the neuron. It carries information away from the soma to the other neurons. Synapse, each standard of axon terminates into small bulb-like organ called synapse. It is a through synapse the neuron introduces the signals to other neurons. Okay, so soma, dendrites, axon, synapse. So working of the neuron. Dendrites receive activation signal from other neurons, which is the internal state of every neuron. Soma process the incoming activity signals and convert it into output activation signals. Axon carries from neuron and sends to it to the other neurons. Electric impulses are passed between the synapses and the dendrites. The signal transmission involves a chemical process called neurotransmitters. Human brain versus artificial neural network. Comparison between the biological and artificial neurons are based on the following criteria. Okay, human brain versus artificial neural speed. Okay, signals in human brain move at speed depending on the nerve impulse. Okay, the biological neuron is slow in processing as compared to the artificial neural network, which are modeled to process faster. Comparison between the biological and artificial neuron based on the following criteria. Speed. The signals in human brain move at a speed dependent on the nerve impulse. The biological neuron is slow in processing as compared to the artificial neural networks, which are modeled to process faster. Processing. The biological neurons can perform massive parallel operations simultaneously. A large number of simple units are organized to solve the problem independently, but collectively. The artificial neurons also respond in parallel but do not execute program instructions. Size and complexity. The size and complexity of the brain is comparatively higher than that of artificial neural network. The size and complexity of the artificial neural network is different for different applications. Storage and capacity. The biological neuron stores the information in its interconnected and in artificial neuron is stored in memory locations. Tolerance. The biological neurons has fault tolerance capability, but artificial neurons has no tolerant capability. Comparison between biological and artificial. Biological neurons are considered as so redundancies, whereas artificial neurons cannot consider redundancies. Control mechanism. There is no unit to monitor the information processed into the network. In biological neural networks, Whereas in artificial neuron model, all activities are continuously monitored by a control unit. That means here, speed, human brain versus artificial neural networks. Speed, the comparison parameters here is speed, processing, size and complexity, storage and capacity, tolerance, control mechanism, characteristics of artificial neural networks. It is a mathematical model consists of computational elements implemented neurally. Okay, the first point is characteristics of artificial neural networks is very important for the examination point of view. Characteristics of artificial neural networks. Very important. The first point, it's a mathematical model consists of computational elements implemented neurally. The second point, large number of highly interconnected processing elements known as neurons prominent in artificial neural network. The third point is interconnections with their weights are associated with neurons. Fourth one, the input signals arrive at processing elements through connections and weights. Fifth point is artificial neural network is a collective behavior is characterized by their ability to learn, recall, and generalize it from the given data. A single neuron carries no specific information. How simple neuron will work? Just see the inputs, corresponding weights. From given above, there are two input neurons X1 and X2 transmitting signal to the output neuron capital Y for receiving signal. The input neurons are connected to the output neurons over a weighted interconnection links W1 W2. For the above neuron architecture, the net input has to be calculated in the way whereas X1 and X2 are the activation from the input neurons. The output Yin of the output capital Y can be obtained by applying the activations for the next input output function. The function be applied over the input activation function. Basic models of artificial neural network. The models of artificial neural networks are specified in three basic entities. This is very important. The models of artificial neural networks is specified by three entities. The models synaptic interconnections, the learning rules adopted for obtaining updating adjusting connection weights, activation functions, activation functions, activation functions, activation functions. The model synaptic interconnections. Neural network consists of set of highly interconnected neurons connected with weights to the other processing elements or to itself. The arrangement of these processing elements and the geometry of interconnection important for the artificial neural network. Important for the artificial neural network. Processing geometry interconnections are important for the artificial neural network. The arrangements of neurons to form layers and the connection patterns formed within and between layers is called network architecture. There are five basic interconnections of architectures. This is very important. There are five basic neuron interconnection architectures. Just see these five. Just these five architectures. Just see these five architectures. One is single layer feed forward network. The other one is multi-layer feed forward network. Third one is single node and with its own feedback. The fourth one is single layer recurrent network. The other one is multi-layer recurrent network. Okay. So once again, I'm repeating three, five. There are five basic neuron connection architectures. One is single layer feed forward network. The other one is multi-layer feed forward network. The third one is single node with its own feedback. Fourth one is single layer recurrent network. Fifth one is multi-layer recurrent network. There are five basically. Okay, single layer feed network. You should observe the diagram like this. It consists of single layer of network where the inputs are directly connected to the output for node with a series of various weights. Like this, they are connected. Multi-layer feedback network. It consists of multi-layers where along with input and output layers, there are hidden layers. There can be zero to many hidden layers. The hidden layer is usually internal to the network and has no direct contact with given environment like this. Single node with the own feedback. The simplest neural network architecture giving feedback to itself with a single neuron like this. Single layer recurrent network. A single layer network with a feedback directed back to itself or to the other processing elements both. Multi-layer recurrent network. A recurrent network has at least a feedback in place. The processing elements obtained can be directed back to the nodes in previous layer. Learning. The most important part of artificial neural network is capable to train learn. It is basically processed by means of which a, a neural net adapts for adjusting or updating the connection weights in order to receive desired responses. Artificial neural net is broadly classified into three categories. This is very important. I want to stop here. Okay, I will explain these categories in the next class. Just look into these three categories. They are heart of the course. I'm highlighted here. Learning artificial neural network is broadly classified into three categories: supervised learning, unsupervised learning, reinforcement learning. Supervised learning, unsupervised learning, and reinforcement learning. What is this supervised learning? In supervised learning, it is assumed that correct target output values are known for each input pattern. In this learning, a supervisor or a teacher is need to for an error minimization. The difference between the actual and desired output vector is minimized using the error signal by adjusting the weights until the actual output matches the desired output. Unsupervised learning. In unsupervised learning, the learning is performed without the help of a teacher or supervisor. In the learning process, the input vectors of similar type are grouped together to form clusters. The desired output is not given to the network. The system learns on its own with the input patterns without help of teacher. This is the unsupervised learning. With the help of teacher, monitoring something is a supervised learning. Okay, the desired output is not given to the network. The system learns on its own with input patterns. Reinforcement learning. The reinforcement learning is a form of supervised learning as a network receives the feedback from its environment. Here, the supervisor does not present. Here also desired output through critical information. Supervised learning has its own applications. Unsupervised learning has its own applications. Reinforcement learning has its own applications. But only the concept is there in the supervised learning. You have to grasp what type of algorithm is suitable for the supervised learning, and what is the concept is there for the unsupervised learning. What type of algorithm is suitable for this unsupervised learning? Okay. What is an reinforcement algorithm is exist? What is the specialty of this reinforcement concept? Okay. So which type of algorithm is perfectly suitable for this reinforcement? Okay. So likewise, we have to interpret and analyze. Likewise, we have to interpret and analyze. Okay. Which type is suitable? Okay. So which type of algorithm, and in coming into artificial neural network applications, using supervised learning, what we have to do? Ultimately, what we can do? Using unsupervised learning, artificial neural network method, what we have to do? Using reinforcement learning method, using artificial neural network methods, what we have to do? Like that, you please try to interpret for my next presentation. Okay. So I think you can understand up to this. I want to stop here. So just one of you just put a message. Are you understand up to this? Okay. Please. Questions also, review questions also I told. Okay. Are you clear up to this? Just observe my chat box. Just put a message. I will send this material to you also. Then you can understand my hard work and efforts. Okay. Are you clear up to this? Just put a message. I'm requesting for a message. Through mail also you can put a message, of course. Through mail also you can put a message to me. Okay. Thank you all. Thank you all. These points what I given innovative and creative presentation is very much useful to you. Okay. I want to stop here.